Howdy, we're on Wikipedia reading about acetylene, or however you speak it, you pronounce it in English. It's the chemical compound with the formula C2H2. It is a hydrocarbon and the simplest alkyne. This colorless gas is widely used as a fuel and a chemical building block. It is unstable in its pure form and thus it is usually handled as a solution. Pure acetylene is odorless, but commercial grades usually have a marked odor due to impurities as divinyl sulfide and phosphine. As an alkyne, acetylene is unsaturated because its two carbon atoms are bonded together in a triple bond. The carbon-carbon triple bond places all four atoms in the same straight line with CCH bond angles of 180. degrees. Remember that. Acetylene was discovered in 1836 by Edmund Davy, who identified it as a new carburet of hydrogen. It was an accidental discovery while attempting to isolate potassium metal. By heating potassium carbonate with carbon at very high temperatures, he produced a residue of what is known as potassium carbide, which reacted with water to release the new gas. It was rediscovered in 1860 by French chemist Marcelin Berthelot, who coined the name acetylene. Berthelot's empirical formula for acetylene, as well as the alternative name quadricarbordioxygene, were incorrect because many chemists at the time used the wrong atomic mass for carbon. So they had to learn too. Berthelot was able to prepare this gas by passing vapors of organic compounds, methanol, ethanol, etc., through a red-hot tube and collecting the effluent. He also found that acetylene was formed by sparking electricity through mixed cyanogen and hydrogen gases. Berthelot later obtained acetylene directly by passing hydrogen between the poles of a carbon arc. Let's check out a carbon arc. What do they know about this? An arc lamp or an arc light is a lamp that produces light by an electric arc, hence plasma. The carbon arc light, which consists of an arc between carbon electrodes in air, invented by Humphrey Davy in the first decade of 1800s, was the first practical electric light. It was widely used starting in the 1870s for street and large building lighting until it was surpassed by the incandescent light in the early 20th century. It continued in use in more specialized application where a high-intensity point of light source was needed, such as searchlights or movie projectors, until the World War II. The carbon arc lamp is now obsolete for most of the purposes, but is still used as a source of high-intensity ultraviolet light. The term now used for gas discharge lamps, which produce light by an arc between metal electrodes through a gas in a gas bulb. The common fluorescent lamp is a low-pressure mercury arc lamp. The xenon arc lamp, which produces a high-intensity white light, is now used in many of the applications, which formerly used the carbon arc, such as movie projectors and searchlights. So now we have plasma and we have, where was it? Here. 180 degrees. So we have electricity. We have plasma, we have gases, we have 180 degrees. And I'm talking about geothermal activity, mountain water, wide rivers, mineral water, hence minerals. I have been talking about quartz, about limestone producing some flammable gas. So how does this 180 relate to all of that? For this we have to go to the world of mathematics. Wolfram math world. Equilateral triangle. 60 degrees. Makes 180. How does this relate to plasma? He can explain it probably much better than I do. That's just a screenshot. Bruce Leybourne. Delta Y electrical circuit geometry of tetrahedron fire elements. So 60, 60, 60, 180 degrees. Fire element in a crystal. Double Delta circuit in quartz is the one in the middle. So there we have, what, 360 degrees? It's just somehow like they belong together, all of them. And I just try to figure out how to explain that thing. Still gathering more information about this. I will put links below. This is this kind of, you could see this as a kind of blog for myself. Like when I make a video, I will put the links below, because every now and then I have to go back to my own videos and check something out from there. And then I don't have to search for too long. Probably if I find a video, because there are quite a few already. And I think it's really interesting how 180 degrees relate to fire and all these kind of things. Flammable gases, geothermal activity, limestone powder, volcanic activity, thermal springs, Romans, our history, Earth's changes, which are so obvious at the moment, since we are entering cosmic cycle, 25,000 year cycle, which is one big cosmic year, approximately. The halfway of it is approximately 12,000 years. And the half of that is 6,000 years, and approximately 6,000 years ago, one story almost everyone knows about this other dude who built an ark and put all the animals there, and there was a whole lot of water and it crashed into a mountain. Ararat. Which is a volcano. I probably have to search for the Bible again and check it out if there's anything mentioned in the Bible about the mountain into which Noah crashed with his ark, or just stuck there. Is a volcano. It's just like, as far as I know, I don't know everything, I'm learning all the time, but it's just mentioned as a mountain, not as a volcano in particular, which is also very interesting. If it's not mentioned, why it isn't mentioned? Maybe the same thing, that first he's releasing a crow, which doesn't come back. And then he releases a pigeon, which brings him a stick. So there is land somewhere. So what happened to the raven, crow, or whatever, crow? Why he put a crow first. What was the reason to choose a raven? And why isn't anything said about this bird again? I think the reason it's maybe simple, because the raven understood that it's free. The pigeon didn't, so it came back, even with a gift. And the dove, or pigeon, or however you put it, isn't known for being very wise. It's just known for navigating through magnetic fields. But it will usually return to the same place where it started, because for whatever reason there are these kind of birds. Maybe Noah knew that, since he probably, like, you know, that's all hypothetical. It wasn't probably a real person. Maybe he was, I don't know. Doesn't matter after all. But let's just think he was, and he lived as long as been told. He probably witnessed the events which happened. He probably witnessed electromagnetics firsthand. Electrostatic stratification of sediments happened in front of his eyes. Mountains were carried away by winds and built again somewhere else, from the top down or from the bottom up, in a different way. They got fused together, so stuff transformed into something else. Limestone probably, maybe into granite. Metamorphic rocks, which are the same thing, that there's, like it said, metamorphic rock is altered by heat and pressure and stuff in consensus geological theory, but they don't explain where it came from exactly. And the thing I found here in Finland, in the plasma rock site, where we have molten metal on top of the rock, you can touch it, it's on top of the rock. There's no volcano doing these kind of things. There's many reports about lightning strikes, and in ancient times lightning strikes were much, much, much bigger. They created the Alps, they created the mountains, they created everything. The electromagnetic potential of our planet and the universe is what makes us conscious. So you just need to have an open mind in order to get a connection to it. And nature will reveal itself and its workings. So that's what I found out about acetylene, about its relation to fire, geometry of nature. Yeah, but I think I'll leave it here. Thanks.